This is episode 2 of the Complex Analysis History series. Let me start with something almost embarrassing. There is a number that the smartest people on Earth took turns insulting for 200 years. Descartes called it imaginary. Newton called it impossible. Leibniz called it something halfway between existing and not existing. And yet, none of them could stop using it, because no matter how they used it, the answers it gave were always correct. Here is today's twist: that 200-year identity crisis was never the number's fault. Happy face. Think about how strange that is. A number gets the worst reviews imaginable, from the greatest mathematicians alive, for 2 centuries, and still refuses to go away. Normally, when an idea is wrong, it dies. This one didn't. So today we will see why it survived, why everyone felt it had no home, and the surprising reason that feeling was a mistake. The number was fine all along. The problem was the map people were using to look for it. Happy face. A quick recap of last episode. Raphael Bombelli did something brilliant. He treated the square root of -1 like an ordinary number, followed the rules, and out popped a perfectly real answer, 4. So everyone learned that this number is usable, even powerful. But that triumph came with a nastier question attached. Bombelli proved it was useful, he could not say what it actually was. Where does it live? Can you point to it? He couldn't. Usable, but unexplainable. And that crack stayed open for 200 years. Happy face. So let's start with the insults, because for 200 years, that is mostly what this number got. Happy face. The first person to give it a nickname was Descartes. Yes, the man who invented the coordinate system. In 1637, in his book La Géométrie, he wrote about these square roots of negatives and said they were neither true nor false, only imagined. He used the word imaginary, and he did not mean it as a compliment. He meant, you can picture these roots in your head, but nothing in the real world corresponds to them. The insult stuck. 400 years later, we still call them imaginary numbers. It is a bit like owning an incredibly hard-working animal and sneering at it with an ugly nickname. The name is insulting, but the animal does the job just fine. Happy face. And Descartes was far from alone. Across those 2 centuries, almost every top mathematician weighed in, and most of them were rude. Newton treated these solutions as simply impossible, and brushed them aside. Cardano, from our first episode, called them sophistic and useless. The strange part is that they were all quietly using this number to solve problems, getting accurate results, while refusing, out loud, to admit it was a respectable number. Their hands said yes while their mouths said no, for 200 years straight. Happy face. This whole awkward situation was captured perfectly by one man, Leibniz. The same Leibniz who fought Newton over who invented calculus. He said imaginary numbers were a fine and wonderful refuge of the divine spirit, almost an amphibian between being and non-being. That sounds mystical, but it is actually precise. An amphibian, like a frog, lives both in the water and on the land, belonging fully to neither. Leibniz was saying, try to call this number real, and you cannot point to where it is, try to call it non-existent, and it keeps handing you correct answers. Stuck in between, at home nowhere. That phrase, between being and non-being, is the sharpest portrait of the entire identity crisis. Happy face. Move into the 1700s and meet the greatest calculator in the history of mathematics, Euler. Euler was completely at ease with this number. Around 1777, he fixed the standard symbol for the square root of -1, the letter I that we still use today. He also produced the formula often called the most beautiful in all of mathematics, using I with total mastery. And yet, here is the catch: even Euler, using it this fluently, still could not say what it was or where it lived. Being good at using something lets people accept it and get comfortable with it, but it does not answer the question of what it is. Knowing how to use it, and understanding what it is, are two different things. Even Euler did not cross that line. Happy face. So where was the actual problem? This is the turn the whole episode has been building toward. Happy face. For 200 years, everyone looked for I in the same place, the number line we all grew up with. Positives to the right, negatives to the left, 0 in the middle. They scanned that line with a magnifying glass, trying to find the one spot where I should sit. Of course they failed. Since I squared is -1, it simply does not land anywhere on that line. So people concluded the number does not exist. But that conclusion is wrong, in a very subtle way. I cannot be found, not because it isn't real, but because that line is too small. The number line has only one direction, left and right. What I needs is a brand new direction, off the line entirely. In other words, the 200-year crisis was never about a flaw in the number. People were holding a one-line map and hunting for something that lives off the line. On a one-dimensional map, you will never find a two-dimensional address. The map was wrong, not the house. Happy face. Let me kill a very common misunderstanding head-on. The moment people hear imaginary number, many of them think, oh, fake, made up, something mathematicians invented for fun, useless. That impression is almost entirely the fault of the word imaginary. We have already seen the truth across 2 episodes. This number wasn't invented for amusement, it was forced out by real cubic equations. And it isn't useless, it handed Bombelli a correct answer, and later it would power all of alternating current electricity and signal processing. The word imaginary is just Descartes' old sneer that happened to stick. It has nothing to do with true or false, and even less to do with useful or useless. A perfectly capable number with an unfortunate name, that is what I really is. Happy face. So how did the crisis finally end? Alongside the geometric picture we will see next episode, there was a harder, more algebraic route, and it came from an Irish mathematician named Hamilton. Around 1833, he found a wonderfully blunt solution. Stop agonizing over what I is, and simply define a complex number as a pair of real numbers, an ordered pair. The number 2 plus 3i just becomes the pair, 2, 3. Then he set rules for how these pairs add and multiply. Addition is easy, add them slot by slot. Multiplication follows one clear rule. And here is the beautiful part, under that rule, the pair 0, 1 multiplied by itself, comes out to exactly -1, 0, which translates back to I times I equals -1, precisely what we wanted. Suddenly I is no longer mysterious. It isn't a ghost hovering between being and non-being, it is just an ordinary pair of real numbers with a clear set of rules. This is exactly how complex numbers are defined in university textbooks today, a fully self-consistent number system you can add, subtract, multiply, and divide in, just like the rails. The 200-year question of what it is got answered, cleanly, by a pair of numbers. Happy face. Looking back, the crisis is almost funny. The number that got insulted as non-existent for 200 years now runs the entire modern world. The alternating current in your walls, the signal processing inside your phone, the MRI scanner at the hospital, satellite positioning, the description of a particle's state in quantum physics, every one of them rests on this imaginary number. No engineer lies awake wondering whether I exists. They simply use it, with confidence. A number once stranded between being and non-being now quietly holds up the workings of our very real world. Happy face. Let's put the whole arc on one screen. 1572, Bombelli shows it works. 1637, Descartes brands it imaginary. Newton calls it impossible, Leibniz calls it an amphibian between being and non-being. Around 1777, Euler fixes the symbol I and uses it brilliantly, yet it still has no home. Then the real insight lands, people were simply looking in the wrong place, the line was too small. And in the 1830s, by giving it a second dimension and defining it as a pair of numbers, the crisis is finally resolved. If you remember one sentence from this episode, make it this: it had no home not because it didn't exist, but because we were using a map that was too small. Happy face. Let's wrap up. A number got called imaginary, impossible, and amphibian for 200 years, and was never thrown out, because it kept being right. The reason it felt homeless was never its fault. The map people held was simply too small, just one line, with no room for a number that lives off the line. Here is a question worth arguing about in the comments. Would you call something real if you can't say what it is, but it keeps working perfectly every single time you use it? Doesn't that sound a little like artificial intelligence today? If you want to see how this crisis is finally put to rest, subscribe and follow along for episode 3. Next time is a great one. At almost the same moment, three strangers, a Norwegian surveyor, a Paris bookshop owner, and the prince of mathematicians himself, Gauss, independently drew the home that I had been missing for 200 years. What does that home look like, and why does drawing it make all the mystery vanish at once? Episode 3, we give the imaginary number a home. That's everything for episode 2 of the Complex Analysis History series.